We're making some pretty good progress on this thing now, but we're sort of back to where we have to do a couple of cosmetic items still. The first one is the high voltage transformer inside the cage of the flyback. It needs to have a little bit better insulation done to it. As you'll notice, if I can zoom in here for you, see all the cracks around that thing? It's cracked like that all the way around, so we need to recoat that with some sort of stuff. And what we're going to use two things to coat that. I've done this before and it worked really well. The first thing we did is, this was found by my good mentor a few years ago, Brendan. It's Dow Corning 732 sealant. It's a clear sealant, multi-purpose type. Good up to 350 degrees Fahrenheit, which is very good. And then once we get that, put on all the way around here nice and neat and everything, we're going to have to let it dry for quite a while. Then we can go ahead and put some of this Corona dope on here, which is used, it says, if you'll read the Corona dope, it says prevents arcing in TV high voltage circuits, which is right there. That's where it says, right there. Yep. So first goes this, and then goes this. Now, one of the reasons we chose the 732 was not just for its high temperature resistance. It also has a very good dielectric strength, which dielectric strength just means the ability to prevent arcing from one surface through the other. Like a piece of mica has a dielectric strength of around 4 minimum up to 9 maximum, and that determines how easily it prevents arcing. It'll stop the flow of electricity. Let me show you a little table I found on the internet. Here we have a table of dielectric constants of various materials. I thought this was kind of neat when I found it. Glass has a minimum of 3.8, maximum of 14.5. That's an insulating strength, the ability to prevent arcing from one side of the glass to the other. Then you come down a little further, you got mica, which is 4 minimum, 9 maximum. That's pretty darn good. And there's all kinds of little, here's one, beeswax, by the way. Let me see if they even have it there. Here it is right here. Beeswax, which is what's probably on the outside of this transformer, has 2.4 up to 2.8. That's the dielectric strength. That's the rating, okay, the constant. And let me see if there's anything else here that might interest us. Here's shellac. Here's one. A lot of people put shellac on transformers. 2.9 up to 3.9. Okay. There's a whole bunch of stuff here. I found it on constants of various materials table. You can look it up and find it. Well, now how does that apply to what we're doing? Well, being the high voltage transformer that this is, there's a lot of voltage that comes out of there. A lot of voltage. And the dielectric strength, as you saw, the dielectric strength of air was 1, and it went all the way up to mica, which was up to what, 9 was it? The dielectric strength of this 732 is 21.6. Very good insulator. It's not like 1,000,000 pounds or 1,000,000 volts of electricity is going to keep flying out of there, but you don't want to take the chance. I'm going to recoat this wax portion, and then we're going to put the Corona dope over the top, which means when we get done, this area will be black all the way around, but it will be well insulated. The last time, or the first time we used this stuff, the 732 and the Corona dope on a flyback transformer, the entire bottom section of wax had completely fallen off and was down on the chassis in another television that I worked on. So we had to do something. All the wire was exposed. It had just melted down into a big glob down in there. So it worked really well, and the TV still works very well. So we're going to do the same thing here. I'll show you how it's done. The first thing we're going to have to do is remove this lid, which gives me a little more swing room where I can get around to both sides. I don't want to have to fight, and take a chance of this thing breaking off or bending or causing any kind of damage. And the only thing you have to do is just remove these 2 screws. You got one right here, one right there. Then I got another one over here. Just remove these 2, and the whole lid comes right off. Well, as you can see, we do have a number of cracks here. Now that we have that back cover off, the top cover off the cage, Got a lot of cracks all the way around, and they go all the way down to the bottom, all the way down. You can't see them too well down in there, but they're all down in there too. Well, anyway, let's get sealing here. In order to do it, I'm going to need an applicator tool, some sort of tool to apply the silicone, or the silicon is what they call it, I guess. Let me see. I always get that wrong. It is RTV sealant is what it is. Silicone rubber. Okay, silicone rubber. And I'll need a little bit of tool of some sort, so I'm going to kind of fashion one. Mostly this thing, it does come with one of these little spouts that's on there, and I can squirt a bunch of it on the transformer. But once I get it on there, you want to kind of shape it a little bit, make it look halfway decent, smooth it down so to get ready for the Corona dope. So let's make our tool here. It's just going to be a little thin thing. Now I went ahead and removed a couple of tubes here, even give me that much more room, and I have my little tool right here. It's just cut at an angle at the top, and I've squirted some of that silicone on there. So now we're just going to go ahead and kind of spread it, smooth it out all the way across there. Just going to take our time, make sure everything is coated real good, just a little section at a time. You can't really just cover the entire transformer and then quick get on top of it real quick with an applicator and smooth it out. Just do it a little bit at a time, maybe an inch, maybe two at a time. That should do it. Takes a little while. Let me keep working on it. Well, there we go. We got it all pretty much covered. It's still a little tacky and a little pliable. I think what I'm going to do is I'll give it maybe 35-40 minutes, and I'll start packing it down with my fingers and shaping it so it's more round and squishes it down into the little holes and gaps and things like that. It's looking pretty good so far. It'll look even better once that Corona dope gets on there. Well, it's the next day. I went ahead and put a second coating and let it dry. And they recommended that you let it dry for 24 hours. So that's what I've done. I let the first coat dry, the second coat dry for 24 hours. It's nice and solid now. This is the kind of stuff, it's like any other silicon, or silicone. It's not going to dry up and get brittle. It stays flexible. So now we're to the point, after it's dried 24 hours, we need to start getting this Corona dope on here. We're going to go ahead. The Corona dope comes with a nice brush. It's pretty good. Now you got to be careful. This stuff is pretty potent. You want to make sure you only put a little bit on. Well ventilated area is the best place to do this, which of course you see I have, right? But just do a little bit at a time. There's no rush to this stuff. There's no rush. So you put a little bit on there, then you let it dry, or just kind of get a little bit sticky. And if the odor or the fumes or whatever start to get you a little bit, what you got to do is just close the top and get out of the area for a few minutes, then come back to it later. No big deal. We can handle anything at all. So let me go ahead and, spot do until I finally get the whole thing covered. It took a couple of coats. You go around the first time and you do your very best to get a good layer on. Then you go around the second time, kind of fill in all the little jagged areas you might have missed on both sides. The idea is to get it covered, It looks real good to me. It looks very well insulated. I don't think there'll be any problems from that thing in the future. Not that there were any problems now. I just wanted to make sure none popped up at a later date. Okay, she's now drying. It dries pretty quick to the touch. But we're going to have to give it another 24 hours to completely set up and cure. So that'll give us time, to move on to the yoke insulator on the CRT. Let's see what we can do with that puppy. There's something else I want to bring up before we go and work on the neck of that CRT. Let's get back to this 25 watt 20 ohm resistor I put in there to take up the resistance of the selenium rectifier. Now that was a lot of overkill. I know that, but I like the fact that this resistor is attached to the chassis acting as a heat sink. Keeps a lot of heat out from underneath this area right here, which is very close to the power transformer. I feel better when I do something like that, and I've got several of these. I picked them up cheap on eBay, and I didn't want to put a 5-watt resistor in there, and then a month or two from now, it burns out. Maybe it's a little bit too low on the wattage. It burns out, and then I have to yank the chassis all back out again. I have to yank the CRT all back out again. I have to remove the Halolight and take a chance of breaking any one of those. You know, the neck of the picture tube, breaking the Halolight bulb. You know, my hands are not as strong, as steady as they used to be, you know, years ago. So everything I do when I'm handling something heavy or awkward or clumsy, it's a risk. I like to minimize risks. So, you know, I can stick a little old resistor there that makes me feel better. It's overkill. The problem is, no, it's not really a problem. It's just that every time my mentor Brendan sees me do something like that, he poo-poos it. He doesn't like that kind of stuff. And probably mostly because he's cheap. He said he's cheap. He tells me he's cheap. You know, matter of fact, he kind of prides himself in being cheap. Me, no biggie. I bought a pile of these for almost nothing on eBay a while back. So he said, and he explained something. He said, look, that thing's going to dissipate the same amount of heat as any 5-watter or 10-watter or whatever. It's going to dissipate the same amount of heat. I know that. You know, the surface area is larger. It just dissipates it more readily. And of course, being, like I said, attached to the chassis, the chassis acts as a heat sink, which I want as much heat out from underneath this chassis as possible. But then he said, well, maybe, you know, you better consider this. The power comes from the diode right here. It goes down through the resistor, back up to here, goes out through this wire and over to this resistor right here, which is a 4.7 5-watt. So, you know, hey, look, no matter what's going on over here, no matter what you put on the chassis and screwed it down and everything, you're still messing with 5 watts right here, which could burn out and cause you to have to pull the chassis and have to pull the, you know, CRT. So everything you attempted to avoid here, this could eventually cause you to do it anyway. Well, you know, guess what? You know, he was right. I know he's right. But I have another one of these. So the problem is I don't have 4.7 ohms. So you know, what do you do? What do you do? You know, it's half one, 6 of one, half dozen others, my mom used to say. Just a little something to think about. Yeah, you know, you're robbing Peter over here, but you're paying Paul over here. Okay? Just something to think about, folks. Now for the yoke. It's just a plastic cover right here and an apron that goes all the way around, and this is the thing that's been flaking off and busting into little pieces. So what I'm going to have to do is remove this and come up with a different kind of apron all the way around this thing. It's only about 3/4 of an inch wide, maybe, all the way around. We'll come up with something. It'll be just glued up underneath this plastic thing. And in order to do this, all I have to do is loosen up this screw right here, remove this band, and, you know, kind of keep in mind what position I had these in. I'm going to kind of put them at, looks like about 3 o'clock for the lower one, and about 6:30 for the upper one. I'll just kind of keep those, but they'll have to slip off. This rubber thing will have to slip off, and then the plastic, hopefully the apron and the plastic will all come off. And, you know, I don't know. Well, I've never done this before, but we shall find out. Let's see how it goes. Well, the band is off. Set that over there. And this rubber thing I've been looking at, it looks like it's just kind of wedged down in between here and the neck of the tube. So, yep, there it is. Either that or I've torn it. I'm not sure which. This should come off all the way around. There we go. That wasn't so hard. Let's see what we got here. Yeah, we have a real thin edge on the bottom down here that went down there between that space. Well, there's our space. Oh my goodness, this might be easier than I thought. Look at that. Look at that. Look at that. Holy moly. Okay, we'll leave that like that. Now we'll take a look at that. Oh my goodness, look at that. Holy, it looks like this whole thing is just going to lift right off. Boy, that thing is really brittle. I doubt that it'll lift. All it is an insulator, folks. Man, that thing was crumbly and shot to pieces over age. Wow. Man, let's turn this thing around. I'll tell you, we'll just leave it like it is right now. I'm not going to be moving it around. I'm going to leave it in the same position. There's the rest of it. Wrapped around those wires. Well, we're not going to... Man, is that thing brittle. Wow. Well, this is getting exciting. I've got everything off. I just took this paintbrush here and kind of lightly brushed away all the little excess pieces. And you know, I think what I need to do now is just go ahead and remove the entire yoke. Now, I know old Brenda's out there, oh, don't do that, don't do that. Well, I'll tell you, I'm going to do it, and I'll tell you why, because I've never done it before. This is a restoration. It's a learning experience for everyone, mainly myself. So if everything is right, this thing should slip right up off the top of the neck of that tube. Just got to be very careful. It gets a little tight toward the top. Just kind of easy. Look at there. Easy, easy. There we go. Alright, again, let's take a look at this yoke. Now this yoke is inside this dotted line right here. All the way up and all the way around like that. And you'll see that on one of the coils we have a 560 ohm resistor across the coil, and we have another 560 ohm resistor, and then up here we have a it's a 56 picofarad capacitor rated at 2000 volts, and then we have a 1K resistor right there across that coil, which is in series with the capacitor. So a 1K, a 560, and a 560. Here's our first 560 ohm resistor across the coil, and here's our second one. Showed them to you before. Now underneath this is where the capacitor is and the 1K resistor. I'm going to have to take a look at that 1K resistor. It's probably good, but I still need to look at it. So what I'm going to have to do is kind of cut this insulator all the way down, peel it back and up, and take a look at it and try to get a measurement. And if it's good, I can cement it back without any problem at all. And the capacitor, I don't have a capacitor checker, and I don't have any 56 picofarads rated at 2000 volts. So I don't know. I hope when I look under there everything's good. Let's do that. Let's just get it on here. I've gone ahead and hooked up my multimeter using gator wires to one side of the resistor. Let me back this up a little bit. One side of one of the 560 ohm resistors, and I hooked the other side of the meter to there. And then we go over and we look at our meter and we get 0.023 ohms. I'm looking for 560. Let me take this down a notch. We're reading about 24.2 ohms across that resistor, and we're supposed to be getting 560. Let's check the other one to see what we get there. Let's hook this here like that. Got to be real careful around these coils. You know, this is delicate stuff here. And again, we get 23.2.3. Why is that? Why are we not getting 560 ohms across here and across there? The answer is pretty easy. I'm putting my multimeter lead here, and then I moved it to here and here. And of course, you know, electricity takes the path of least resistance. So what's happening is I'm reading through the coil to the meter. We're going up through the coil. We're not even reading the resistance of the resistor. The coil is the least resistance. It's going to go that way. So each one of these coils ohms out about, you know what, 23.2 ohms. And we're going to run into somewhat the same situation here. However, if I can connect onto one end of the coil and the other end of the capacitor, I should be able to read this 1K without having to do any removing it from the circuit. But if I want to check this for sure, this resistor and this resistor to 560 ohms, I'm going to have to remove one end from each one. Until further notice, I'm going to go ahead and call this capacitor good. There's no obvious signs of burns or anything like that. Everything in there looks really, really good. You know, it's kind of a tacky way to do it, but since I don't have anything to really test it out, it's easy to get to at a later date if I need to. Now I got to seal up, you know, this cover right here, and I can use either some liquid tape to function as a cement, or I can use some of this silicone. I decided to go with the silicone because it's easier to remove the silicone. It'll peel right out if the capacitor ever does need to be replaced. So I'm going to just gook a little bit up in there, and then we'll just kind of hold it together like that real good, maybe a little bit of overlap until she stays. And she'll be right back where she was. And the old cover over the top of the capacitor and the resistor is drying. It's really secure now. No problem at all, back where we were. Well insulated again. And I have disconnected, let me get a little closer here. I disconnected both of the 560 ohm resistors from their respective terminals. One there, and the other one came off a terminal right there. And I got the leads kind of sticking up, and we're going to go ahead and measure them out of circuit, and we're supposed to get 560. Now here's our little old multimeter. Let's see what we get. The first one, 5. Wow, that's pretty close to 560. Let's try the other one. Let's move this lead over to this one over here now. If these are good, I'll solder them back up and we'll be done. 592. I'm still going to go ahead and accept that. You know, some people get real nervous. They say, oh my God, I can't believe those little tiny delicate things, and this is such a delicate you know, and vital thing to the operation of the CRT. You know, I would be a wreck, you know, taking that apart. Not me. Not me. It just takes practice, and you have to go very slow. Never get in a hurry. Take your solder, extract it, take your lead, remove it, clip off part of the end of the lead so you don't have a ton to have to put back through the hole. Because in the old days, you know, when they made these things, they would wrap them around and around and around. There's no need for that, okay? All you need to do is stick it up through the hole, put a slight hook to hold it, and solder it in place. That's all it needs. Okay, we're going to wrap this video up here, and I was going to go ahead and get to the insulator on this that goes over the top of this mess, but we'll do that next time to keep this video from being way too long, okay? All right, until then, this is John.